Right, welcome everybody. We're going to get started now. Welcome everyone to our webinar, Emerging Soil and Water Contaminants and Land Contamination Risk Management. Today, we're joined by Paul Nathanail. Paul's a chartered geologist and specialist in land condition. He's a director of specialist contaminated land consultancy, Land Quality Management Limited, or LQM. He chairs the board of directors of Silk Register Limited and also chairs his local neighbourhood forum. He's currently leading the team drafting the SCHEER guidance on PFAS in soil and water and is deputy chair of the Nicole PFAS working group. Paul has over 30 years of experience in land contamination, and he's seen emerging contaminants emerge. So today, Paul will describe the characteristics of emerging contaminants of concern, explore how our existing policy and technical tools can deal with them, and provide reassurance that the UK approach to contaminated land management is comprehensive and robust enough to ensure that new development is safe and that unacceptable risk to current land use is identified and dealt with, as well as diving into why most PFAS are rightly considered emerging, whilst some are not. Paul will explore other emerging substances of concern to ensure that, at the very least, preliminary risk assessments consider them. This webinar is part of the science theme of our Future of ES23 Horizon Scanning and Foresight project, where we're bringing together interdisciplinary perspectives on horizon scanning from across the environment. The work is supporting the sector to manage risk, plan ahead, and work towards a better future for the environment achieved through transformative change. Look forward to the end of the year when we'll be publishing a vision statement on the future of the environmental sciences to bring all of that together. But back to the matter at hand. As always, there'll be a chance for your questions at the end of the presentation, so please do submit those in the Q&A function at the bottom of your screen at any point during the presentation, and then I'll ask those questions on your behalf a little bit later on. So thank you for logging in, but for now, I'm going to hand over to Paul. Paul, thank you for coming on, and over to you.
Joseph, thank you very much indeed for the invitation, and a metaphorical tip of the hat, the IES for putting on the session. So this is part of a program, as Joseph said, looking at where the environmental sciences are going over the next 50 years, recognizing that IES itself is half a century old. My name is Paul Nathanail. I'll introduce myself properly in a minute. But the six themes that the ES23 project is looking at are megatrends, science, regulations, us, the workforce, the role of work that we'll do, and looking into the future. And I thought it would be useful to spend a couple of minutes looking at the megatrends that are the first of the six themes. The diagram on the right is from a European Environment Agency report focusing on the European Union. But when you start looking at those megatrends and you apply them to land contamination, you begin to realize that they are all relevant to us. Let's start at the bottom. Approaches to governance. Even within the UK, we have 4 different countries, 4 different bodies of legislation, one of which is still getting legislation from Brussels. 2 of them have devolved parliaments, and 1 takes its laws directly from Westminster. We are still seeing an increasing environmental pollution burden from industry, from waste disposal, from mining activities, and so on. And we are clearly seeing the effects of a changing climate, and in particular, more extreme weather events that have an impact on how our contaminants behave and on how some of our remediation processes might function going into the future. There is an increasing desire for nature-based solutions, but we're also building over more and more of our natural habitat, and we are being quite tardy in bringing in tools for protecting or indeed enhancing biodiversity. And I'm really looking forward to seeing how the new biodiversity net gain rules come in later on this year. There is an increasing competition for resources, and that will mean that we will have to do more with what we have. We might want to reuse more of what we've already got in order to avoid having to go back to primary sources. The multipolarity of the world is manifesting itself partly in geopolitical influence, but in terms of the science, we're beginning to see very deep capabilities emerging in different parts of the world. And you can see that in the scientific literature, the peer-reviewed literature. So that's beginning to influence what is happening in the knowledge space. And I think for one thing, we should be very grateful that, at least for now, English is the lingua franca of science. You'll notice that continued economic growth has a question mark against it. At some point, we run out of planet. So the fixation with economic growth without curtailing consumption, ultimately, as the Club of Rome said many, many years ago, well, we are going to face a crunch time. The accelerating technological change is partly resulting in more and more synthetic chemicals coming onto the market and therefore eventually finding their way into the environment. But we're also benefiting from the ability to detect more substances at lower limits of detection and be able to do more things with them in order to manage the risks. A great deal was learned about disease burden and the risks of pandemics, and that's both improved our understanding of the value of monitoring, of understanding where things are happening, looking for trends in wastewater, drainage water, in disease, and that will help us understand how chemical-related issues behave as well. More and more of us are living in urban areas, and in particular on coastal urban areas, which of course provides us a link back to the climate change. And these cross links can be done all over the place, but I'm not going to draw you a spider's diagram. And then the first of the global mega trends, the last one I want to come to now, is diverging global population trends. We're seeing many countries having an aging population. We are seeing others which are really young. And when you start looking at the demographics, that is going to present real challenges to the workforce and the ability to have the right kind of people in the right place doing the right things. So really exciting 6 themes. How does that map onto land contamination? Well, that's the summary that Joseph read to us earlier, so I'm not going to go through that. And this is my introduction. This is a picture on the right of me holding a molecule of a model of a molecule of PFAS, the 8-carbon sulfonic acid, and I'm taking part in a radio panel for ABC, the Australian equivalent to Radio 4, and I'm trying to explain to a radio audience what the PFAS molecule looks like. I'm going to skip over the rest of the stuff here, but I've been privileged to work in this sector for over 30 years, and I was delighted when IES joined the specialist in land condition qualification. They've been a breath of fresh air to the Silk PTP. Joseph mentioned the guidance we're writing for SCHEER, good practice guidance on PFAS in soil and water, very much a team effort with Ian Ross from CDM Smith, Geraint Williams from ALS, and Judith Nathanail from LQM. When that project is finished later on this year, SCHEER are launching a PFAS forum to provide a single point e-platform for discussing PFAS issues, providing opportunities to meet, share information, improve good practice, learn from the rest of the world. And if you'd like to learn more about that, then Joanne Kwan at SCHEER, and here is her email address, would love to hear from you. I've simplified UK contaminated land legislation, which of course is a devolved matter, into this diagram, which has 4 boxes. We have historic contamination and new contamination, stuff that happened today. We have ongoing land use, and then we have changes in land use. So part 2A, the contaminated land regime, is dealing with historic contamination and the current use of land. Planning is looking at the impacts of historic contamination on a change in land use. Now, what's important to realize is that by and large, our legislation is chemical agnostic. Part 2A talks about or tasks local authorities to look at substances in, on, or under the land. Substances, not a specific list or named chemicals. The planning regime in its various dialects across the 4 countries of the UK essentially wants to make sure that new development is safe, and contamination is one of the material considerations that you have to take into account. Other countries have specific lists of chemicals on their legislative shopping list or to-do list, if you will. And if you're not on that list, the regulators don't have power to look at those substances. So we have a regime and we have a policy framework that allows us, and in fact requires us, to consider any and all substances to make sure that they are not posing high levels of risk, and if they are, to do remediation in order to make sure that those risks are brought down. Now, there are various definitions of emerging contaminants, and what I've done here is distilled the essence from various definitions from the USGS, the US Environmental Protection Agency, the OECD, the Joint Research Centre of the European Union, the Norman Network, and others. So rather than giving you a series of different definitions, I'm trying to give you a flavour of what an emerging contaminant might look like. It's something that we might have a newly discovered source. We didn't know that it was somewhere, and we now know about that. We realized that there might be a new exposure pathway, either because nobody looked or because only recently can we look at those concentrations. We've only just found it in water. Concentrations are higher than one might have expected. There is a lack of knowledge of the dose-response relationship, the toxicology, or indeed the assessment criteria that you might apply in water or in soil. Where there is some toxicity, the dose response may not be fully understood or may be contested. If you look at the literature on PFAS, the epidemiological studies, the dietary studies that have informed some recent regulatory values are highly contested within the toxicology community. The chemistry and their behavior in the environment are not particularly well understood. We don't have well enough controlled chemical properties or the influence that those properties will have on fate and transport in soil, in water, in the atmosphere. They don't have to be new chemicals, but it might be that the chemical's been around for a while, but the presence or the significance of that presence is only now being realized. We're only now waking up to it. It might be that the substances have been detected as one-offs in an ad hoc way, but we're not routinely monitoring them, whether at a British or an EU or more broadly. But in essence, if you put all that together, what there is either a perceived or a potential or a realized threat to human health and or the environment. So that's what flavor an emerging contaminant comes with. In essence, it's about significant uncertainties about where they are, how they're going to behave, and what they're going to do with us. So in terms of PFAS, the headline substances, PFOS, PFOA, PFHXS, and there's a few others, are well enough known, well enough understood to essentially it's not really fair to call them emerging substances. But the PFAS universe includes 12,000, I've heard of much, much larger numbers than that, many of which we don't know where they are, we don't know how they're going to behave, and we don't know what the dose-response relationships are going to be. So some examples of the kinds of things that might be emerging: medicines, both human and veterinary medicines. These are designed to be biologically active. Some of the active ingredient will pass into the organism and do some good, but some will pass through and enter into the environment. Plant protection products, the pesticides and herbicides that we increasingly use at industrial scale farming. Personal care products, the lotions and potions that we put on ourselves to protect ourselves, improve our appearance, and so on, then get washed away at the end of the day and end up back into the water environment. Household cleaning products, lawn care products to control the wrong sort of green and encourage the right sort of green, agricultural products, and, as I've said, some substances that meet the definition of PFAS, and some that may well be fluorinated, but are not within the definitions of PFAS that have been adopted by different regulatory bodies around the world. And these are just some examples. There are others that we can come back to. So I thought I'd see what regulators say about emerging contaminants. So the EPA has a website on emerging contaminants and contaminants of concern at federal facilities owned by the Department of Defense, by the Department of Energy. And I've just listed the 10 that appear on the EPA website. Now, some of these are quite familiar to us. For example, trinitrotoluene is a substance for which we've calculated a screening value as suitable for use level. RDX is another one that we've got a suitable for use level, so we know enough to do that. Nanomaterials, currently, their use for environmental remediation in the UK is banned under a moratorium, but we have done work at a European level through the NanoRem project to demonstrate that nanomaterials can be injected into a contaminated source zone and degrade contaminants without being able to travel and impact groundwater quality elsewhere. Probably the more famous non-PFAS emerging contaminant is 1,4-dioxane. And then you get the occasional strange ones like tungsten that if you delve into it, you'll see why tungsten is listed by the EPA. So I thought I'd look at a couple of these in a bit more detail. The polybrominated diphenyl ethers, PBDES, these are used as flame retardants in plastics, in upholstery, in electronics. And they can get into the environment, into the water, the soil, the sediment at manufacturing sites, through leachate from waste disposal sites and so on. They've been found in air, in sediment, in surface water, and in both fish and other marine animals. They don't really biodegrade too much. Depending on how many bromines you've got attached to the basic core diphenyl ether structure, the more brominated congeners tend to bind to the sediment or soil. The smaller, less brominated ones tend to behave very differently. Volatilization from the soil, not too bad. The more brominated, the heavier, bigger congeners tend to be less volatile. So this is the beginnings of understanding, but the reason I put this slide up there was to show you that we've got a feel for how PBDEs behave. But look at how old some of this information is, 2001, 2009. This is not current cutting edge stuff. You think we've had 20 years to become familiar with these substances. Is that justifiable? Well, this is the chemical properties of PBDEs, the ones that you'd be familiar with: water solubility, vapor pressure, the KOW, the KOC, Henry's law constant. So we've got a pretty good handle on some of these PBDEs. Okay, well, maybe it's the toxicology we don't know well enough. No. Here we have reference doses, the US equivalent of a tolerable daily intake for oral ingestion for a variety of different congeners. We've got an American carcinogenic slope factor. We've got drinking water. So we know something, we know enough about the dose response to give PBDEs toxicity value. Okay, well, is it that we can't calculate the soil screening levels? Well, no, same document. These are the soil screening levels for a residential and industrial land use and soil, and for tap water, for drinking water. So you begin to wonder why PBDE, or how PBDEs earn their place on this list of emerging contaminants. We know more than perhaps we might think we do. So let's look at another one. This is, excuse me, trichloropropane. So propane has 3 carbons, and trichloro tells you you've got 3 chlorines. And then the 1, 2, 3 at the beginning tells you that you've got a chlorine on the first carbon, another one on the second carbon, and another one on the third carbon. Now, this is a synthetic manufactured chlorinated hydrocarbon. You often find it where you have other chlorinated solvents being used as well. It was used as a solvent, as a cleaning agent, as a degreasing agent. And it's also found as an impurity where soil fumigants were being produced. Its chemical properties mean that it's not likely to absorb to soil. It's likely to leach into the groundwater. It's likely to persist in the groundwater, and it's a DNAPL. Again, we have pretty good handles on the chemical properties of trichloropropane. And we have some toxicity values. We've got an oral reference dose. We have a inhalation reference concentration, which is in the wrong units for us in the UK, but you can convert that to a TDI for inhalation. And there are soil screening levels for the residential and industrial land use. So again, TCP doesn't really, or 1,2,3-trichloropropane doesn't really earn the spurs of an emerging contaminant that I shared with you earlier. This is a much longer list, the US EPA's contaminant candidate list. Now, this is list number 5. So yes, there have been lists 1, 2, 3, and 4. And this goes back to my UK legislation is chemical agnostic. These are contaminants that are not currently regulated under the US Safe Drinking Water Act. They are known or anticipated to be in public water systems, but they're not subject to regulations. And very long list here. We can see tungsten that I've mentioned earlier. Excuse me. We can see 1,2,3-trichloropropane and 1,4-dioxane. So some of these are more familiar than others. Some of them we really look at and think, well, why aren't they being regulated? So methyl mercury, for example. Again, this goes back to the UK having a robust and comprehensive legal system simply by dint of not having a list of chemicals. And it goes back to the real importance of understanding how a site has historically been used, what chemical processes were going on, and therefore what substances would have been used and therefore could have been released into the environment. What about nearer home? Well, the Committee of Toxicity, to give it its full name, the Committee of Toxicity of Chemicals in Food, Consumer Products and the Environment, was meeting earlier on this morning, 10 o'clock this morning. It meets every few months. And this is the agenda. I've highlighted 2 items on here. The COT was looking at a European level an opinion on bisphenol A in foodstuffs. There is a proposal to reduce the TDI, the tolerable daily intake, from 4 micrograms per kilogram body weight per day to 0.04, so 2 orders of magnitude much lower. If that was to happen, then it would mean that the exposure of both typical and high-level consumers would exceed that new TDI. So that's the discussion that's going on at the moment. Bisphenol A looks like this. You've got 2 phenyl rings here connected through a carbon, and that's the structure. And then you've got 2 OH groups at either end. So that's bisphenol A. Let's look at that in a little bit more detail. And the other one I'm going to come back to is inorganic arsenic in the maternal diet. So the discussion around bisphenol A is whether or not COT agrees with this 2 order of magnitude reduction in TDI. And if they realize and accept that that's the case, well, how are they going to protect consumers who are now exposed to levels above that tolerable daily intake? So bisphenol A is kind of there on the cusp of being an emerging contaminant. You would think that arsenic is a well enough understood substance and a well enough understood contaminant not to be needing such current attention. But the margin of exposure approach has been used to compare exposures to benchmark dose levels. And what's been found in the past is that rice drinks, which had been given as a substitute for either breast milk, formula, or cow's milk, is sufficiently laden in arsenic that the advice is not to give rice drinks to toddlers and young children. Indeed, the exposure to inorganic arsenic, that's what the I means, from dietary, and this is us, non-dietary sources, could result in margins of exposure of less than 10. Now, the margin of exposure is a useful, simple ratio, but the regulatory and policy significance of different levels of margin of exposure hasn't been sorted out yet. But as you approach unity, as you approach the exposure equaling the benchmark dose, then there is an indication there that there is a possibility of risks to human health. In the young age groups, toddlers and young children, the dietary exposures are much more significant than exposure to soil and dust. Now that's fine, because at the moment in land contamination terms, we deal with arsenic as a non-threshold substance, so we don't consider background exposure. But we're beginning to see a little bit more light being shone on inorganic arsenic, and if the efforts to reduce it in food and water continue, then there may well be increased pressure to reduce exposure from soil and dust as well. At a European level, there is a European Commission committee, the SCHEER committee, or the SCHEER committee, on health, environmental and emerging risks. And this is from their headline, what do they do? Their areas of activity includes looking at the impacts of antimicrobial resistance, new technologies such as nanotechnologies. You can see the rest there, but the bit in the bold at the bottom, the interaction, synergistic effects and cumulative effects of risk factors, which includes all of the above, and ways of assessing new risks. Now, historically, we've not really had enough of an insight to look at synergistic effects. Classic example of this is smoking and inhalation of asbestos has a synergistic risk on lung cancer. We've dealt with cumulative effects with things like total petroleum hydrocarbon criteria, working group fractions, We're beginning to see similar approaches for some of the PFAS. So the tolerable weekly intake from EFSA looks at the sum of PFOS, PFOA, PFHXS, and PFNA, but increasing attention from SCHEER. They are currently looking at protecting animals that are used for scientific purposes, and their current focus is on zebrafish and on some passerine bird species. The passerines are about half of all bird species. The zebrafish are a commonly studied fish on which we are learning something about PFAS. I'm not going to spend too much time on the PFAS universe other than to point out that the family of some 12,000 substances has a very broad range in toxicity, persistence in the environment, mobility, and bioaccumulation potential. And we cannot use the two stars of the show, if you will, PFOS and PFOA, as surrogates for all the others. Their breadth of behaviors and effects is just too great. About a month ago, HSC, the Health and Safety Executive, published its ROMOA on PFAS, its risk management options analysis, and they've provided groups of both per and polyfluorinated substances, and I could highly recommend looking at that document for more details as we begin to carve up the PFAS universe into smaller and smaller galaxies and solar systems. What makes PFAS interesting is that what you start with in the environment may not be what you end up with, and you might go through interim transformation products and end up with what are called terminal products, which are persistent and often toxic. And it's that transformability from something less bad to something more bad that is a current challenge in the PFAS environment. All that brings us back to the really fundamental importance of, in land contamination risk management, LCRM terms, the preliminary risk assessment. If you don't understand the nature and the location of where different site activities have taken place, you won't have a good enough conceptual site model, and you will either have to do much more sampling and analysis, or worse, you might leave behind contamination undetected. So a really good understanding of the historical uses of the land is probably the most important protection in managing liabilities and assessing risks properly. So a reminder of the flavor of emerging contaminants. I've gone through this, and bringing it back into the ES23 scope. Yes, all the mega trends are important. We're seeing trends towards more computer-based modeling to understand how these contaminants are going to behave. The regulators are probably going to err on the side of over-conservatism. Where the environmental sciences come into their own is, I think we're going to have to move not so much towards more interdisciplinarity, but towards multiply disciplined people. People who have enough knowledge of chemistry and biology and toxicology and geology and ecology to delve into the knowledge and apply that to solving problems. And I think the job is going to increase in scope from using our knowledge to decide what to do, and increasingly to tell the communities that will be impacted by the work that we're doing what's going on, why it's going on, and make sure that they've understood and come on board with the choices that they're going to have to live with. So the future, I think, is going to be increasingly complex, and because of the easy access to information, increasingly contested, which makes our role as professionals much, much more central. So I'm going to leave you with a reminder of where we are with ES23. I think the environmental sciences are going to have to become more quantitative. A lot more work is going to be done on computer modeling. A much more systems approach is going to have to be adopted. We're going to have to learn the language of multiple disciplines, both the natural sciences and the social sciences. Our knowledge will have to be deeper, but we will have to be able to communicate that more widely. So with that, thank you, and I hope I've allowed some time for some questions, Joseph.
Perfect. No, thank you so much, Paul, for that fantastic webinar. I think you gave us a view into the world of emerging contaminants and contaminants more generally, perhaps, all the way from that chemical makeup through to the regulatory dimension and everywhere in between. And I think you tied that really well back to that purpose of the PRA and LCRM really well. I know you're keen to get into Q&A, so let's hop right in. So attendees, if you have any questions, please continue to pop those in the Q&A box. There are about 200 of you who've been on the call, so we'll try and get through as many of those as we can. The first question I'm going to ask actually comes from me, Paul, just to get us started. And I'll abuse my privilege on that. It's actually about something you said right at the beginning in the bio, which is that you've seen emerging contaminants emerge. And I think the logical question that comes from that, because you've talked to us about emerging contaminants, the ones that are on our radar already, is what do we do about the contaminants that aren't on our radar yet? Maybe because they don't even exist yet. How can we get future ready for an increasingly complex world of substances, chemicals, and pollutants?
Okay, the ones that don't exist yet, our first line of defense is legislation like the REACH legislation, whether it's at UK level or at EU level. The challenge there is the flow of new substances coming onto the market is probably overwhelming. But those are our first lines of defense, which is why I would point people to the HSE RMOA on the PFAS. The challenge, just for one, that little subset of chemicals, just the 12,000, there are over 1,000 pages of PDF that either are in the RMOA or were written to inform it by the Environment Agency. 400 pages of RMOA and 900 pages of substance-specific environmental risk assessments. So REACH is the first one. The analytical laboratories are the superheroes, and they are increasingly giving us tools that will tell us what's there without having to have a standard to say, I am looking for that molecule. So we're seeing things like high-resolution mass spectrometry coming into play to give us fingerprints of contaminants. But it's going to be a real challenge.
Perfect, thank you. So we're going to get a little bit specific now with some of these questions. So the first one's going to be about nanomaterials. So Connor asks, you mentioned the moratorium on nanomaterials. Which parts of the UK does it apply in? Where can people get more information about that? And do you know if it includes the use of injected colloidal carbon for the treatment of hydrocarbons? Okay, so let me start with the last one. Colloidal carbon is currently used as a remediation technique, so that's a slightly easier one. The moratorium was promulgated by DEFRA, and it was an understandable moratorium waiting for extra information. It goes back a number of years, and the findings of the NaNoRem project, if you go onto the CLARE bulletin, you'll find, onto the CLARE website, you'll find 10 or 12 bulletins that came out of that project, showed that nanoparticles, iron and iron-based nanoparticles, can be injected safely into contaminated source zones and deal with things. My knowledge of the minutiae of Northern Ireland, Scotland, or Wales use of DEFRA moratoria, I'm gonna avoid that question and say I don't know whether it applies outside England, and I wouldn't dare to tread into devolved administration's terrain. Thank you, Paul. I think that's a wise choice. So the next question we have comes from Elijah, who's asking about PFAS specifically. And the question is, do you see PFAS contaminants being introduced as those tested for within a routine suite of testing in the near future? So perhaps a little bit of commentary around what's being done now. Okay, so at the moment, if you've got a site where Class B firefighting systems were installed, or you've got an airfield site or a fire training area, then you really ought to be testing for PFAS. There are a number of other industries where PFAS were used, and there are, of course, waste disposed of in landfills from which PFAS are known to leach out. The Dark Waters film that tells the story of PFOA from a DuPont-owned landfill site
is probably the most high-profile example of that. The drinking water inspectorate requires 47 substances to be tested in England and Wales as drinking water. And we have commercial laboratories offering analytical suites in soils of between 19 and 24. So there is every reason for PFAS to be part of the normal toolkit of analysis that you are testing for at the moment. Nuclear Bulletin TB22 came out about a month ago, authored by Ian Ross, whose name I gave earlier, telling us what PFAS were used at what kind of sites. So, yep, it's there now. It's mainstream now.
Absolutely, Paul. And while we talk a little bit about approaches to some of these things, we've got another question from an attendee who's asking if you can talk a little bit about the development of approaches for the remediation of land subject to these kinds of emerging contaminants.
Can I answer that by focusing on PFAS? And if there's anything else that the questioner wants, then come up with a follow-on question. The destruction of PFAS molecules is really difficult. It's very, very energy intensive. It can be done, but it cannot be done in situ realistically, and it cannot be done at large volume. So the remediation strategy for PFAS in soil and water is you either break the pathway or you extract the contaminated medium, you concentrate, and then you destroy the concentrate. So a current example of a site that I'm involved in the UK, contaminated water is extracted. It's put through a foam fractionation system where the PFAS is concentrated into the foam, and that foam is then separated out and that's sent off for destruction. So extract, concentrate, destroy is the current thinking in terms of PFAS remediation, if pathway interruption isn't appropriate.
Thank you, Paul. You've answered a few technical ones, so I'll throw you a slow ball with this next question. We've got a question from Edward who asks if there's a link to the audio of the ABC radio talk where you talked about PFOS.
I don't know if there is, Edward. It was a couple of years ago now, but there is something called the PFAS podcast in Australia by an Australian journalist, and she's interviewed a number of people over the last 2 or 3 years. So if you want something to listen to on PFAS, then I can recommend the PFAS podcast. There's one of me recorded last September at the Cleanup Conference. There's one by Ian Cousins, one of the big names in PFAS worldwide. So the PFAS podcast is where I would point you to, because I don't know what ABC's equivalent to iPlayer might be.
Perfect. Thank you, Paul. And if we get a link to that, we'll pop it in the description of the YouTube channel when this goes up on the IES YouTube. So if you subscribe to that, then you can get the link through to that as well. I think we've got time for one very quick final question. So maybe just a summary of thoughts about different regulatory regimes. So you talked a little bit about SCHEER and the work that's going on in the EU. Are we beginning to see any differences in the regulatory regimes between the UK and the EU on this? And do you think there might be any consequences of that?
I'm smiling because what we're doing is slapping a Union Jack over an EU flag, quite honestly. There is some cracks appearing. Last autumn, the Committee of Toxicity published a statement on the EFSA opinion for PFAS on the tolerable weekly intake. And the COT's conclusion was that the tolerable weekly intake that EFSA produced, which of course is non-binding on us here in the UK, was based on poorly constrained data, let's put it like that, using modeling that the COT weren't happy about. But with gritted teeth, the COT said, we've got nothing better to offer instead. Now that tells me that tolerable weekly intake is a low dose, that if you're below it, you really have got nothing to worry about. But if you exceed it, it doesn't necessarily mean that you go straight to remediation. But that is almost the exception. We're still looking, and the HSE Ramoa document on PFAS is the classic. we're still looking at the EU REACH database for much of our information. And if we're not looking there, we're looking across to the states and what the EPA has put on its databases. There will be chinks of exceptions, but they will be the exception rather than the rule at the moment, because this stuff is just so complicated and expensive to bottom out.
Perfect. Thank you, Paul. That's all we've got time for, I'm afraid. So if you have any other questions, you'll have to subscribe to the YouTube channel, and when the video comes out, you can continue discussing and arguing in the comments below. For now, though, thank you so much, Paul. That was a fantastic webinar today. That is all that we've got today, though, attendees. So thank you for logging in. I hope you found it beneficial and informative. Don't forget to record your attendance at this webinar in the IES CPD tool, and you can do that by logging into the members area. And if you're currently watching on YouTube, please subscribe to the channel, like the video, and hit the bell to gain notifications for new content. If you're interested in our Future of ES23 horizon scanning work, you can find all the details on our website, or you can send us an email to get directly involved in that work and what it means for you. For now, though, thank you again so much to Paul for a fantastic webinar and discussion today, and thank you to everybody else for attending and taking part. For now, have a lovely day, and thank you.